Hello viewers, welcome to the last section, Debugging Techniques. In this section we will learn about debugging our application using GDB, debugging memory leaks with Valgrind, and detecting memory leaks. Now we move on to the video, debugging our application using GDB. In this video we will learn to add breakpoints. The first step in fixing a bug is to reproduce the issue. It is crucial to capture the steps involved in reproducing the bug very efficiently. Experienced QA engineers will know the importance of capturing detailed steps to reproduce, as developers will find it difficult to fix an issue if they can't reproduce it. From my point of view, a bug that can't be reproduced can't be fixed. One could make guesses and beat around the bush, but can't be sure whether the issue has really been fixed without being able to reproduce the bug in the first place. Debugging strategies help a great deal in quickly reproducing, debugging, detecting, and fixing issues efficiently. Debugging tools help narrow down the issue through step-by-step execution with breakpoints, variable inspection, and so on. Though debugging the issue step-by-step may be a time-consuming task, it is definitely a sure-shot way of nailing down the issue, and I can say that it pretty much always works. Here is a list of a few debugging tools for C++. GDB is an open-source CLI debugger. Valgrind is an open-source CLI, good for memory leaks, deadlocks, racing detection, and so on. Affinix Debugger is a commercial GUI tool for GDB. GNU DDD is an open-source graphical debugger for GDB, DBX, JDB, XDB, and so on. GNU Emacs GDB mode is an open-source tool with minimal graphical debugger support. Kdevelop is an open-source tool with graphical debugger support. Nimiva is an open-source tool that works well in the GNOME desktop environment. SlickEdit is good for debugging multi-threaded and multi-processor code. Debug tools are there to rescue you from tedious efforts. The GDB debugger is an open-source CLI tool which is the debugger for C++ in the Unix-Linux world. For Windows platforms, Visual Studio is the most popular one-stop IDE with inbuilt debugging facilities. Let's take a simple example. Open the Atom editor and here you can see the main.cpp file of the ex1 directory. We will compile and run this program. Let's go to our terminal. Now type the command g++ with the file name main.cpp. As you can see, our program has compiled successfully. Let's run this program using the /a.out command. The bug is obvious. As you can see, we obtained vector entries after sorting in descending order. We accept vector entries after sorting in ascending order. Let's go easy with GDB learning. Let's first compile the program in debug mode, that is, with the debugging metadata and symbol table enabled. Type the command for debugging. Let's start debugging our faulty application to detect the bug. Let's first start GDB with the /a.out command. We have started GDB. Then let's add a breakpoint at main to perform step-by-step execution. As you can see, we have added a breakpoint in the main.cpp file at line number 46. After launching our application with GDB, the main command will add a breakpoint to the first line of the main function. Now let's try to execute the application by using the run command. As you may have observed, the program execution has paused at line number 46 in our main function, since we added a breakpoint to the main function. At this point, let's execute the application step by step. Type next command. You can also type a short command for next, that is, n. Execute the n command 2 more times to see the resultant output. Let's add 2 more breakpoints at line numbers 29 and 33. From this, you will understand that the breakpoints can be added by the function name or by the line numbers as well. Let the program continue its execution until it reaches one of the breakpoints that we have set. Type the continue command. As you can see, the program execution paused at line number 29 as it gets invoked whenever the sort function needs to decide whether the 2 items must be swapped in the process of sorting the vector entries in an ascending order. Let's explore how to inspect or print the variables this number and RHS object number. Type print this number. As you can see, it prints value as 100. Then type print RHSObject.number. As a result, it prints value as 10. Go back to our Atom editor. In line numbers 29 through to 35, did you see the way the operators are implemented? In this highlighted block, the operator checks for the less than operation, while the actual implementation checks for the greater than operation. In line numbers 33 and 35, a similar bug is observed in the greater than operator method as well. That is, the operator checks for the greater than operation, while the actual implementation checks for the lesser than operation. While the sort function is supposed to be sorting the vector entries in an ascending order, the output shows that it is sorting them in a descending order, and this highlighted code is the root cause of the issue. Hence, let's fix the issue. With these changes, let's compile and run the program. Go to the terminal and type the Q command, which will exit from the GDB. Let's type the command which will compile our program. As you can see, we have compiled our program successfully. It's time to execute our program using the /a.out command. This is the output that you'll get. We obtained the vector entries after sorting in ascending order. Cool, we fixed the bug. Needless to say, you will have recognized how useful the GDB debugging tool is. While we have only scratched the surface of the GDB tool's capability, it offers many powerful debugging features. In this video, we learned to debug our application using GDB,